Greetings to everyone. We are from Group A, course Chemical Engineering Laboratory 1, Lab 1. And now we will present the experiment 3 and 4, that is pumps and valves. Our lecturer is Dr. Harimatul Sakia binti Zainuddin, and our demonstrator is Mr. Ismail Abdullah. Here is our group members: SHIM Chilsi with matching number 216913. NURUL FARIHA with matching number 214646. NURUL FARISYA with matching number 216297.
Session. Piping system has been introduced to transport water to various parts. In piping system, pipes must be included with pumps to overcome the dynamic friction losses in pipes. In this experiment, centrifugal pumps are used, which is a mechanical device that is designed to move a fluid by means of the transfer of rotational energy from one or more driven rotors that called as impellers. There are two types of centrifugal pumps, which are horizontal single-stage centrifugal pump and vertical multi-stage centrifugal pump. The differences between these two is horizontal single-stage centrifugal pump has only one impeller rotating around the shaft, while multi-stage pumps have two or more. Here is the objective of this experiment, which is to measure the operating characteristic of a pump. And for the theory and working equations, to pump an incompressible fluid, power is needed to make sure the fluid can flow through a straight pipe and a cross-sectional area. We can get theoretically from the formula of the power as the rate of performing work. However, the actual pump only delivers a smaller amount of actual power than what equation 1 computes. Therefore, a widely used technique to describe the functioning pump is the pump efficiency solution, while equation 3 is used to express the pressure drop as the loss of pressure heat and the acceleration of gravity. The work done by pump per unit mass of fluid will result in decreases in the pressure heat, velocity heat, and potential heat of the fluid between point 1 and point 2. And then by applying the Bernoulli's equation between point 1 and point 2 in previous figure will result this equation. And since the difference between elevations and velocities at point 1 and 2 are negligible, the equation will become like this, which is work over mass equal to pressure difference over density. And by dividing both sides of this equation, we will get this equation. And finally, the right side of this equation is the manometric pressure heat.
Okay, so before we move to our procedure, so this is the device that we use to conduct this experiment. So next, we move to procedure 1, start up. We need to make sure that water tank level is at least half full and the cable data was connected to the computer. And we need to turn on the power supply and P1 pump and also the process water. After that, we need to make sure that HB3 and HB4 valve will close while HB5 and HB6 valve will open. Next, the speed control potentiometer is fully rotated to the lower setting in anti-clockwise direction. And the computer need to be switched on and the readings were monitored. Next, we move to procedure 2, which is pump performance at fixed loop flow rate. And the pump will start by pressing the button on. The speed control potentiometer was gradually turned to 1500 RPM in clockwise direction. And the flow rate of the HB7 fix has decreased to be roughly 35% of its maximum value. So in this experiment, the maximum value is 1675 RPM. Next, the flow rate, speed, power, and differential pressure were measured once the pump is stabilized. So the same step were repeated for following RPM values, which are 1575 until 579 RPM. Next is procedure 3, which is pump performance at fixed pump speed. The pump was turned on by pressing its start button, and the speed control potentiometer was gradually turned clockwise to achieve the maximum speed was about 1678 RPM, and the HB7 was gradually adjusted so that the flow rate was roughly 75% of its maximum value. And the maximum speed for this experiment is 75 RPM. Flow rate, speed, power, and differential pressure were measured once the pump is stabilized. And the same step were repeated for 70 and for flow rate value underwent the identical procedures again. and additional intermediate readings were collected if needed.
Now I will continue with the result and discussion. For the first table here is the raw data when the freight flow rate is fixed at about 35% of maximum value. And here is the raw data when the pump speed is fixed at about 75% of its maximum value. And here is the direct data when the freight flow rate is fixed. And we calculate the head loss, theoretical power, and the pump efficiency from the raw data table 1. And here is the derived data when the pump speed is fixed. And we calculate all the data from raw data table 2. The graph here shows the relationship between head loss and flow rate under fixed fluid flow rate. From the graph, the observation is the head loss increased with the flow rate. This is because the increasing in volumetric flow rate contributes to the increasing in speed of fluid. And the increasing of speed of fluid will lead to the increasing of friction. And we know that the frictional loss will reduce the amount of total head produced. So it means that the head loss will increase. Moreover, it could be observed that the differential pressure increased with the flow rate from the table. And the head loss is directly proportional to the differential pressure. For the second graph, it shows the relationship between head loss and flow rate when the pump speed is fixed. The graph shows the inversely proportional relationship between head loss and flow rate, which is different with the result we get just now. It might be because of the head loss is directly proportional to the differential pressure. And in this case, the differential pressure increased with a decreasing volumetric flow rate as shown in table below. And the increasing differential pressure will lead to an increasing in head loss. Hence, the head loss is high when the volumetric flow rate is low. The graph here shows the relationship between efficiency and volumetric flow rate for two cases. And based on the graph, we observe that both efficiency increase with the increase in volumetric flow rate. So it could be said our experiment results are consistent with literature values. Because based on the single stage pump curve below, the efficiency of the pump increased with the flow rate until it reached the highest efficiency. So the efficiency is directly proportional to the volumetric flow rate before it reached the highest efficiency. Moreover, the efficiency is directly proportional to the theoretical pressure as well. And from our experiment result, both theoretical pressure increased with the flow rate from the derived tables. Hence, their efficiency increased theoretically with the volumetric flow rate.
Okay, next, so the conclusion of this experiment is into examine and dealing between the pump performance, the fixed and fixed fluid flow rate or fixed pump speed, respectively. Two procedures are carried out, and the data of speed, flow rate, motor power, and pump head were gathered. And in addition, in this experiment, the maximum machinery that can reach is only 1678 RPM. And from this experiment, we can also conclude that power increases as the flow rate increases at steady speed. Differential pressure, theoretical power, head loss, and efficiency are all calculated in this experiment. And lastly, in this experiment, it is assumed that the friction factor is constant. Next, there are also recommendation steps that can be taken so that we can improve for the next experiment. Firstly, to prevent systematic random error, the experiment should be conducted or run 2 to 4 times, and the average result and then can be computed. And the speed must also be checked before the experiment in order to determine the fastest speed that may be operated. And we need to make sure that all the pipes are circularly connected to make sure to prevent the energy loss. Lastly, the pipeline needs to be cleaned often because the dirt can accumulate inside the pipe, so it can limiting the experiment potential for further head loss. Next, this is all the references that we used to prepare this presentation value and prepare this video presentation. So that's all from us. Thank you.